Okay. So we say that our graph is connected. शायद हमने ये पहले भी इसको define किया हो. Whenever there is a path from every vertex to every other vertex in the graph. Okay. ये condition true हो तो हम कहते हैं कि the graph is connected graph. So for example, this is a connected graph. Okay. But for example, this is not a connected graph. Because up यहाँ से you don't have a way to go from this vertex u to this vertex v. Okay, there is no path from u to v. So this is not a connected graph. Call it a disconnected graph. For the disconnected graph, there is something else that we define. The thing is called connected components. Connected components are maximal subgraphs that are connected. Maximal connected subgraphs. So for example, इस graph में, इस disconnected graph में there are two connected components. एक आपके पास ये है और एक आपके पास ये है. Okay. इसके अंदर अब इसको मजीद छोटा नहीं कर सकते. You can't say that this is two connected component because you need it to be maximal. Okay. जितना बड़ा उसको आप कर सकते हैं, you should do it. So this has two connected component. How many components do you have in this graph? There is a single component in this graph. Okay. Can you guys hear me?
Yes, sir.
Okay. Okay. Does it make sense? Connected component का जो concept है?
Yes, sir.
Okay. All right. When you go to directed graphs, this connected component concept becomes slightly more tangled. So, for example, you can have a situation like this. जिसमें you have all right. So the thing is, you have a graph. But the thing is, let's say आपके पास vertices हैं 1, 2, and 3. Now you can go from 1 to 2. You can go from 1 to 3. You can go from 2 to 3. But you can't go from 3 to 1. Okay. And you can't go from 3 to 2. Okay. Which makes it weird. How do we define? Because the paths are defined one way. Okay, you can go from 1 to 3, but you can't go from 3 to 1. तो इस केस में we define connected components in two different forms. वो जो हमारे लिए important है ज़्यादा, उसको हम strongly connected components कहते हैं. A strongly connected component is a maximal subgraph जिसमें all vertices can go from one to another. Okay, so इस केस में जो maximal connected component है जिसमें 1 होगा, so 1 can go from 1 to 2, but you can't go from 2 to 1. So 2 is not in the same strongly connected component as 1. You can go from 1 to 3, but you can't go from 3 to 1. So 1 is alone in its connected components. This is one connected component. Similarly, you can go from 2 to 3, but you can't come back from 3 to 2. So 2 is another connected component. Similarly, 3 is another connected component. Okay, so in the directed graphs, you need to pay attention to the directions. Strongly connected component is a subgraph जिसमें you can go from u to v and v to u as well. So let me try to, for example, make another example. Or let's pick the directions like this. Okay, so यहाँ पे आपके पास, let's say this is A, B, C, and D. Can anyone spot strongly connected components here?
It's B, sir. Actually, no, it's not. Um,
C.
so C के connected component में और कौन-कौन सी vertices हैं?
ABC.
Yeah. So the thing is, C say you can go to A, but you can also go from A to C as well, right? Because you can go from A to B, B to C. So there is a path from A to C, and there is a path from C to A. Okay. So C and A are in the same connected component. Similarly, you can go from C to B and B to C, which means B and C are in the same connected component as well. But you can't go from D to C, okay? Which means that D is not in the same connected component. So this is one connected component, ABC, and here is another strongly connected component. So there are two strongly connected components uh, in this graph. Okay, so this would be sort of, I'm not going to spend a lot of time on this, but you will study algorithms to find strongly connected components in a directed graph in the next semester. Any questions here before we see the problems?
No, sir.
All right. So here's the problem. The problem says that if the number of edges are more than this many, then the graph must be connected. Is it true? Assume it's a simple graph or undirected. Okay. So someone tells you that the number of edges in this graph is n minus 1 choose 2 plus 1. Okay. More than that. Then somehow you need to conclude without looking at the graph topology that the graph must be connected. How do we do this? By the way, if you have exactly this many edges, okay, then I can claim that the graph can be disconnected. And it's not that hard to see. If you put one vertex on one side and all other vertices in another part and make this completely connected, okay, make this a complete graph on n minus 1 vertices. So the number of edges in here would be n minus 1 vertices connected with every pair is connected. So there are n minus 1 choose 2 edges there. And the graph is disconnected because there is a vertex which does not have a path to another vertex in the graph. Okay, so but the claim is if you add one more edge to this graph, the graph will become connected. It does become connected in this case, but in general, it says that if you have this many edges, you will have always a connected graph. Any idea, clues, how to do this? Before I randomly start picking people. Eamon की आवाज नहीं आई आज.
Sir, I was facing quite a bit lag. इस वजह से
Okay.
मुझे कुछ बातें क्लियर नहीं हुई तो मुझे रिकॉर्डिंग देखनी पड़ेगी.
Okay, but you understand what a connected graph is, right?
Yes, sir. Yes, sir.
Okay, so now I give you a graph जिसमें बहुत ज़्यादा edges हैं, n minus 1 choose 2 plus 1, and you need to show me that the graph is connected. वैद randomly pick करो यार लोगों को. Let's
Okay.
mark them absent यार. हमने एग्जाम से पहले काफी लोगों को निकालना है.
Okay. आमना अकबर.
आमना अकबर को हमने लास्ट टाइम भी कुछ बोला था.
No, sir.
No, Amna, are you there?
बोला था क्लास में.
Okay. Okay. Do you have any idea how to prove this? So let's do an example. Okay. Let's say your n is 5. Okay. So n choose 2 would say that there are 6 edges. Okay. Oh, sorry, 6 plus 1, 7 edges. Okay. There are 5 vertices and there are 7 edges. And now you need to show that this graph is definitely clear, no matter how you arrange these edges. How do you show this?
सर इसको इस तरह से कर सकते हैं कि if the graph is connected then it must have at least n maximum number of edges must be n choose 2 and if it is not connected then we'll be like dividing the components into n1 and n2.
Okay.
So if like n1 is equals to 1 or n2 is equals to 2 sorry, n1 is equals to 1 or n2 is also equals to 1. There must be less than n minus 1 choose 2 connections. So for n minus 1 choose 2 edges, the graph must be connected.
Yeah, it's a good start, but इसमें थोड़ा सा एक part ये है कि what did I just do? So the hard part is you can't assume how many vertices would you have in a component. And so we are doing this by contradiction, okay? By contradiction, which means you have this many edges, n minus 1 choose 2 plus 1, and G is disconnected. Okay, if G is disconnected, you will have a vertex U and a vertex V, so that there is no path from U to V. Okay, so what we do is that हम ये कहते हैं कि let's make a list of vertices which U has path to. Okay, हो सकता है कुछ vertices तक path हो, I don't care, maybe किसी से path ना हो. Okay, so let's put them in this part X. Okay, और बाकी जो vertices हैं जिस तक U का path नहीं है, let's call them Y. Okay. Does anyone know how to move from here onwards? So we know that we don't know X में कितनी vertices होंगी. Okay, let's call it K. But we know that K is at least 1. Okay, K is definitely at least 1. Or Y में we can say that there are n minus K vertices. Okay, so
the total number of vertices will be k choose 2 plus n minus k choose 2.
Yeah, so the maximum number of edges would be कि ये सारे आपस में connected हैं और ये सारे आपस में connected हैं. Okay, which is k choose 2 and n minus k choose 2. Okay, but how many edges are missing? What are the missing edges? The missing edges are the ones कि हमने ये कहा है कि none of these vertices are connected to any vertex here. Okay, so the missing edges are, how many edges are missing?
K.
K times n minus k, right? This many edges are not there. None of these guys are connected to anything here. Okay?
Yes.
Okay, so but हमने ये कहा कि our graph contains at least this many edges, which means कि ये number must be less than or equal to n minus 1. Okay, इसमें अगर आप if you add n minus 1 so you would get n choose 2. Okay, now you just show that this is not possible for all k. Okay, So it's nk minus k square is less than or equal to n minus 1. How do I show this?
N minus 1 divided by n is greater than k minus k squared.
Yeah, so n minus 1 over n is greater than or equal to k minus k square, k into k minus 1. K into
So
1
actually,
minus
no, we can't.
We
n
can't?
because
No, n is not multiplying with k square as well. तो ये गलत है.
Okay, okay, sorry. Okay. So we show that this thing, this k into n minus k, is an increasing function of k. Okay. Which means that if we increase k, the value of k minus nk would actually increase. Okay. It will get a maximum value at somewhere and then it will decrease. So we need to find out, okay, just let me think about it. How do you show that? Just a second. This should be, let me confirm. So n minus 1 choose 2 is n minus 1 into n minus 2 over 2. And we have plus 1. और इसमें से हमने to subtraction plus n into n minus 1 over 2. अच्छा. And n minus 1 over 2 into n minus n plus 2 ये खत्म हो जाएगा और हमारे पास 2 which is n minus 1. Okay, so this number needs to be n minus 2. It's not n minus 1. Okay, यहाँ पे if I add n minus 2 to this part, so I would get n minus 2, n choose 2. So this is n choose 2. Okay, and now I need to show you that this is minimized at this is minimized when k is equal to 1 or when k is equal to n minus 1. इसका कोई आसान सा नहीं बनता. Let me try to write it down. So it's k into n minus k, and I need to show you that this is less than or equal to n minus 2. So I get nk minus k square is less than or equal to n minus 2. Let me bring n here, and I get nk minus n is less than or equal to k square minus 2. So I get n into k minus 1 is less than or equal to k square minus 2. Okay. हाँ, इसका कोई आसान हल नहीं है. You will have to do quadratic formula आपको apply करना पड़ेगा on k, and that will give you the value when this is minimized. Okay, I'm skipping this. Okay.